Hello everyone, welcome back to Algebra 2 class. Today we are going to continue our conversation about sequence and series. And today we are going to introduce a type of sequence which is called arithmetic sequence. I believe many of you probably already know this idea from Algebra 1. So before the lesson, let's have a quick warm-up. So this warm-up asks us to find the next 4 terms of this given sequence. And this sequence, as you can see, is actually defined in recursive formula. So the first one, A1 as 3, so which is indicate the first term, which is 3, and an plus 1 equals an plus 2. So this one sometimes this kind of symbol is actually always can be confusing because sometimes you don't get used to see this kind of symbol. You may wonder, is that, an meaning a times n or something like that? So I just want to remind you again, if you get used to see this, n stands for like the current term. And for n plus 1, so you can consider this is actually the term after the current one, which is next term. So the most important part to understand the recursive formula is to consider what this formula, what this equation telling us the relation between these 2 consecutive terms, which is we can interpret this as, in order to get a next term, I need to add a 2 for the current term. So we already know the first term, which is 3. So you can list, this sequence like this way. So the first term is 3. And then to get the next term, as we mentioned, we need to add 2. So to get the next term, I need to use the current term to add 2, which is 3 plus 2, 5. So the next term is 5. And same thing, to get the next term, I need to use the current term, which is the one before this, to add 2, which is 5 plus 2. Remember, A2 meaning the value of the second term, which is already just had it, which is 7. So we continue, and it's going to be A3 to get the next term, so 7 plus 2, which is 9. And A5, remember, next 4 terms. So after the first one, 1, 2, 3, 4. So it's going to be this. So if we just come back to observe this sequence, of course we can just continue. As long as we keep adding this, we'll continue this sequence. So this sequence probably already figure out the pattern, which is clearly indicated here, which is adding 2, adding 2, adding 2, adding 2. So this is we define this recursive formula, but we clearly see the pattern is actually just adding 2 to get the next term. So this type of sequence, when we add the constant number to get the next term, this kind of sequence is actually the sequence we are going to introduce today, which is called arithmetic sequence. So let's quickly check these 2 examples here. Arithmetic sequence, as we mentioned, we keep adding the same number. So let's check what if this first one is arithmetic sequence. Is adding 2, is adding 2, is adding 2. And same is all apply. It all applies the same pattern here. We're adding the constant number, which is 2. So this is arithmetic sequence. Again, I just want to remind you this doesn't mean you always have to add number. We can also subtract the same number. So this number doesn't have to be always positive. Let's check this one. We add a 5, we add a 5, we add a 5, we add a 5. So this one, as you can see, they keep adding the same number 5 to get this sequence. So this is also arithmetic sequence. So some terms we are going to use. As we can see, we keep adding the same number. This same number here we called common difference, which we use D to stand for. So as you can see, common difference is actually the difference between the 2 consecutive terms. 4 minus 2 is 2, 6 minus 4 is 2, 2, 8 minus 6 is 2, so this is common difference. Same thing for here. Any after, next term to subtract the previous term, you will get the same constant number. This is called common difference. So for arithmetic sequence is we always add the same number. But as I mentioned, this common difference can be positive, can also be negative. For example, so if I continue this pattern, you will notice that for this sequence, we keep subtracting 2, right? So it's decreased. So sometimes it's not always increasing, it is decreasing. So for this case is, common difference is negative 2. So it doesn't have to be always positive, it can be negative here. So this is, the general idea of arithmetic sequence. Next, we are going to introduce, as we mentioned, any sequence can be defined. Either we use a general term formula or we use recursive formula. Then can we use this kind of ways to define arithmetic sequence? That will be the next focus. Let's check. So, to make sure our language is consistent now, so general term formula, as we mentioned, any, general term to define as, to define by using n. We consider, we also call this explicit formula. So from now on, we are going to call this explicit formula versus recursive formula. So it's actually just to define the general term. So it's really, really the same idea. But I noticed a lot of extra books, textbooks are talking about using explicit formula. So I just want to make sure when you see this word, you know exactly what does that mean. So that's why from now on, instead of calling general term, we just call this explicit formula. Okay, let's see how do we define this. Let's check this sequence. First of all, you can definitely pause the video and to check what do you notice about this sequence. Some students probably already noticed it's actually just adding 2, right? And we know the first term is 3. So the general term will always say explicit formula, basically asking you, if I want to get any random term, how do I use n to define this? Or how do I get from a1? Or even any terms before that. So this is basically explicit formula asking us, how do we extract this one to do this? So the idea is, let's think about this. Let's see the pattern. So we know in order to get the next term, we need to use the first term to add 2, which is, remember, this 2 is common difference, right? So we need to add a common difference to get the second term. And then to get a third term, we need to keep adding. This is our second term. When you add one common difference, like a common number, to get the second one, and then I need to add a common difference again to get the third term, right? So I just keep adding. So if I just continue, you'll probably figure out, in order to get a fourth term, how many times I need to add that common difference? 3 times, right? I need to add 3 times. So from the first one, add 1 more, second one, 1 more, third one, then 1 more, fourth one. So I can just continue. So the question is, if I need to get any random term, n can be 10, n can be 19, it can be 100, how many times I need to add that common difference in order to get this nth term? Some student probably figure out it's just n minus 1 time, so it's less 1 time. So consider this is the first term, then add 1 more, second term, 2 more, third term, 3 more, fourth term. Continue n for n minus 1 times the common difference. This is actually called explicit formula. So in this formula, I can just use any term, I can use the first term and the common difference to predict any terms in this sequence. And I can, we can use this in many different ways. For example, as long as I know, maybe I know any random term in the sequence, I can Also common difference, I can go back to predict what is the first term. So a lot of way to use it. So just want to remind you again, this is called explicit formula. We use this one to generate any terms in the arithmetic sequence. Now, as we mentioned, any sequence can also be defined in recursive formula. So let's check, how do we define arithmetic sequence in recursive formula. So we're looking at the same sequence here. We know the common difference as 2, as we mentioned, right? So the recursive formula is very straightforward. We look for the relation between the 2 consecutive terms. So we always need to define what is the first term, the value of first term. Again, the reason I didn't, sorry, let me read this part. I didn't put any value because for this specific sequence, we know the first term is 3, but for any random sequence, it's just, we put a first term value here. And in order to get a next term, let's see a second term. Let me just write it down to make it very, detailed for this one. To get next term, I need to add this common difference. Anything. For any third term, I need to use the second term to add 2. So this is recursive. Remember, recursive formula tell the relation between the 2 consecutive terms. So in general, let's rewrite this recursive formula. So recursive formula, I just want to remind you all again, always provide 2 information. What is the first term? Again, the value of the first term. And also, in order to get a next term, what do you need to do to get the next term, which is adding common difference. And that's it. That's our recursive formula. Recursive formula, as you can see, very straightforward to tell you what is a common difference here. What do you need to do to get a next term? You need to add a common difference, right? Very straightforward. And also, as we mentioned, you need to use a previous term to get the next one in the recursive formula. So the first term must be given in order to generate the other terms in the sequence. Okay, so that's 2 ways to define arithmetic sequence. As I mentioned, we can definitely use these 2 formulas to just do different kind of practices. So the next video, we are going to look at the 3 examples about this type of the sequence, and we are going to use this type of formula to help us to have a better understanding for this type of sequence. Okay, thank you so much, and I'm going to see you again in the next video so we can do more practice together to have a better understanding for this type of sequence so we can all master this topic. Thank you so much for watching this video. See you soon, everyone.